Here we're using segment tree to query the minimum max, so and update, right? So basically we have this array here. Okay, let's say, yeah, for this sample, okay, this sample we have this array here. Which array? This one here, right? Let's say for this array, let's write down. Okay. Yeah, let's say we have 0, 2, 0, 5, and 3, and 1, right? This is a 0 base, so 0, 1, 2, 3 is array. We want to looking for the minimum and the max, right? So last time we saw the sparse array. Sparse array we can do the query and we didn't build a update. We have sparse array. We can vary. After we have sparse array table. Remember sparse array table we have here, and this is 0, 1, 2, 3, 4. This is, and we build 0, 1, 2, 3. We build the sparse array table. After we're building finished, it's very easy to query. You can any time of query, just two query, right? Let's say, yeah, just query the if you, let's say you want to, yeah, this is a sparse array, but sparse array we didn't update. So for segment tree we have update. The idea is like this. Idea is a bunch of array. You cut this one to half, right? If you cut this one to half, this one top one is the whole range. Top one is the whole range. So like this one, let's just start this top on 1, okay? Top one is the whole range, and go here. Let's say this is 6. Not like this one is a perfect square. Like it. Let's say this is 6. So 0, 1, 2, 3, 4, 5, 6. This is 6. When you cut a half, definitely this is 0 to 2, and this is 3 to 4, right? So you start this one maximum, this one max, this is a minimum or max, whatever, right? So right now we should have a minimum. So we have 0 here, and the whole range is up to here is 0. Up to here is no. This one is 1, sorry. This is index. This is real value, right? So for this one, minimum should be 1. Change the color 1. And here, 2, 2. 3 and 4 is 1, right? Oh yeah, we actually gotta have some. Yeah, we have the sample 2, 2, 2, 5. Let's say 8, 3, 1, something, maybe 2, right? So basically this is 1, this is 1, this is not 2 or 2, changing this one, change the value to 8, right? After 0, 2 is split, right? After 0, 2 is split, you split to half and say 0 to 1, cut to 2, and here 2 to 2, right? So this one, 0 to 1 here, 0 to 1 here is 2, 2, 2, 2, right? 2 is just himself, right? Like this. So you build all this one, you get half and half, half. Similar with the segment tree also have log, also is half, and here we do the same thing, right? We have like index 3, 4, build another nodes, index 3, 4, and 5, 5, something like that. And we keep query here. So here is 3, here's 1, and here is 2. Yeah, then we keep going here. This is until the last one, like 3 and 4, last one, right? So here is the tree here. So when this one build here, and this one can update. So when you update here, you only need to update like this side, right? So let's say this 2 change. This one change, right? This one 2, before it's 2, we change it to, I don't know, yeah, 2, we change it to, let's say, -1, right? If this one changes to -1, therefore this one gotta change to -1 here, right? And going up, this one will be that guy, so this one also gotta be -1, and -1 compared to above one, also -1. So basically you just similar, you go through that part, do the update. So this one doesn't matter, right? This one doesn't matter, you didn't even touch this part, we have this part. So basically this is save a lot of times, kind of n log n, right? That's the idea. So let's do this sample. So we do a segment tree here. Let's do this question sample here. Yeah, here we cut to, let's say, 10 to red and 0. We have this 4, right? Before this perfect square. So this one, the top level is 1. 1 is represent 0 to 3. And after we go to 2 and 0 to 1 and 2 to 3. After they go 0, 1, 2, and 3, right? So this is 202, and we'll change the color. Say this is 202, 205, this is 3, this is 1, right? Right, going up here in this range is 202, and in this range should be 1, and top level should be 1. So basically we build this query and try to update that part, right? So this is the sample one. So here, this code is wrapped into the class, so we don't need to study how they write. So we just like copy the code. So basically, see here the top 1, 0, you know, for the 1 here is 1, and yeah, we go here. So this array 1, right? So the left side, this is 202, right? 0 to 1, right? And go inside here. This one is turned to this index have the similar calculation, secret calculation. You need a revert back. So this 2 and represent this 2. If this is 2 and represent this is 1 represent here, right? So this is 1, 2, 3, and keep going. In this array here, we stored in the 1D array here. Let's say, for example, this color, right? So we have this 1 and 2 and 3, 4, 5, 6, and 7 here, right? So you go back to here, you will say this is the 1 is 1, 2, 3, right? And the 4 is this one, 5, this one, 3, 1. So similar like this. So basically, when you query back, it's just follow the same rule here, right? You have same rule to build it back. And when you update, also very easy. So this is for segment tree. Segment tree is for update. The range updates this minimum and the max, and also query this one is faster. So sometime when you have array here, you changing the one value here, then we want to quickly find out which one is faster, which one is slow. This is the way to do segment tree. When CCC test the segment tree, let's study CCC S4. This one is segment tree, and so basically you got a subway station and 1 to n, and your target is go to 1, go to n, right? It's always 1. But the station one day have 1 train. It start with kind of like a 1 to n permutation. You can every day pick a 1, So the first day, he gave you first day is the initial first day like this order. 1, go to station 1, go to station 4, 3, 2, right? This is the initial one. And every day they switch, 3 and 4. This is the index, 3 and 4, and 2, 4, so index, right? Also, they have another way to work it. So from 1 to 2, it's gotta be work as 1 minute, it's kind of like that. And he asked the faster way to do that. So as usual, this how to think this problem. So first of all, we gotta solve the one sample, right? So I think this one also like math. It gave you some hint or step by step what you can do here, right? So n doesn't matter. N is the how many station here. This is related to brute force, and W is the W is the how many like how many walking distance, right? And D is how many days switch here, right? Yeah, first we gotta figure out if not switch. Let's say not such switch things. We see here that eventually we gotta go 200K. 200K is a mark, right? So even we got this one, we got like 7 mark, totally 15 mark, right? So what we gotta do here is we gotta solve this problem first, then think about how to optimize, right? So first, let's say give you 1, 4, 3, 2. How to solve this problem? Which one is the fast way? So this is the key. So how you think? Then we think the optimize how to do that, right? How to switch. So how to do switch faster, right? So okay, let's do the analyze here. Is oh wait, what is our answer here? So yeah. Yeah, basically this is our initial one. Initial one is a 1, 4, 3, 2, right? 1, 4, 3, 2 here. You can compare. This one is easy, right? One go for take 1 second. Let's do this, right? So how to do that? So if I give you any order, how can I find out what's going on here, right? Which is the fast one. So we gotta go. There's another condition we gotta, first of all, yeah, we gotta read the question very careful. So it's so yeah, we gotta spend more time to read that question, right? So no tricky, stay here, right? Yeah. So this start from AM in the morning, right? You begin your day trip to the answer. Each minute you may either write this one or this is not the key. Yeah, so the key is subway line. Subway line will be like yeah, see, from 1 at 6 a.m. in the morning and take 1 minute to each station, right? So that mean what? That mean like yeah, see, n minutes after 6 a.m. the train will reach the 6 m plus 1. So that mean like what that means. So here, so we got this is the keywords, right? So the train is like never stop. Train keep go this way. So first minute go here. This is first minute. Second minute go here. Third minute go here. So arrive at each station is the same time, right? So this time is decided here. So I arrived at the second station on 3 minutes, right? So what that mean is the first rule is you jump off the train and go back. It doesn't get anything. If I like say here, go back here. If I want to go to, I jump here and I do some funny move and come back to the station. Then go to here. It takes the same time. Takes some time. So you jump off the train and get on the train, do the same thing because the train arrived at every station on the same time. So you don't need to do that, right? So the question turned to the easy one. So first this is part, yeah, we've stuck in here, then we cannot go ahead, yeah. So once we figure out this one, we can say, okay, So we can say, okay, so because now we can think about this brute force, this part, right? We can say if 1 go to here, or 2 go to here, 3 go to here, what time it is, right? So we can brute force everything here. So this costs nothing, right? So then we quickly realize only this one is fixed. This one is fixed. This one changing. This one is fixed. So that question difficult level is the first test this one and that one, right? There's two different things. For this one, what do we do? This one is BFS, right? So it's BFS. So this is BFS, right? And the question is want to go to 4 here, right? The question is always want to go to 4. So no n. This is, let's say this question n equal to 4. The question you want to go n, right? So for this BFS, it's special BFS. We only want to know. When we pick any station arrive at 4. Which one is the fast one, right? So this is. When we have this one, we build a reverse like notes here. So here, once C solve, let's say so, we target is 4, right? Target is 4 because this question is not like yeah, target is 4. So we do the adjacent set is like we add 1 here, right? We add 1 here, right? So. And the other one like 2, right? 2 will be 4 will be 2. This 2 will have 1. And this is also this way, right? This way. I don't know, 1. No, 4 have 3. This is this one. 4 will have 3 here because in this he gave it a raise 3 go to 4, right? And here is 4 go to 1. Here is like get rid of this one. 1 go to 4 here like this. And here is what? Here is 2. 1 will go to 2. 1 will go to 2, right? So in the beginning we build a like adjacent set. Array list, right? So we add this one. Usually we build a 2-way, but this way is 1-way. So in our adjacent set, we just add this one to the array list, add this one to that list, right? We don't need to add both. Don't need to add this one back. No need. Okay. After we just do the like BFS, right? BFS. Yeah. The BFS we want to know the quickest way go here, right? Go 4. So we start BFS is 4. We know which one go with BFS. We don't need to pick any number. We just start with BFS 4. The usually is a 4 here. We have generic 4 is like this, right? Generic is like this, 4. Let's say 4 have a bunch of nodes. N. This is N. Have a bunch of nodes here, right? And it go here, 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 here. Go keep go here, and it go here, right? So we need to build a distance array. Distance. So not distance with the level here, right? So what level here is build things, right? So this one we only need to build access array. So this visited, right? So we need to build this array to show us already coming. We don't need to come back here, and then every time we come to here, we need a so like this case. So we have this case, right? This one go to 2, this one go to here and come back here, right? Yeah, let's say for this case, okay, 2, right? That kind of case, okay? Yeah. So for this kind of a BFS, we don't need a checking. Usually for the BFS, we need a checking the we need a checking if this one, we need to checking this one, which one is smaller, right? If it's smaller, we update this one and put this one back to the queue. This is another BF. Usually what should we do? For this one, because a special case, right? Special case, we don't need to put back. Like this case here, because this is one level, right? And the BFS, we put this one in the queue. This is a queue here. This is 1, 2, 3. So 1, 2, 3 will be in the queue. Do the one by one, one by one, one by one, 2, 3 will be the queue, right? The BFS. And after, what do we do here? We're looking for one. Have any children here? We have this one. So let's say this one is the 4 and the 5 and the 6, right? 4 and 5. After you put one out, and you're looking for the children, or 4 and 5, so put a 4 and 5 in here, right? Yeah. Then after you put a 2 out, you find a 6 is here, and you put a 3 out and no children, like this. Then you're looking for the 4, are looking for 2 gone, 3 gone. Then you're looking for 4, 4 gone. Now you're looking for 5 here, and the 5 have 6 already accessed, so you don't need to pull back. So 5 gone and 6 were gone. This is the visit. This is for the visit, and the level also okay, because the level on top always in the queue first. So this one, 2 here is in the queue first. It will never jump into here. So therefore, you just need to keep adding the distance. No need to compare the distance. Keep go down. So this is how you do BFS. Once BFS is finished, right? So once the BFS is finished, we know this one go to here. Let's say 4 station go to this. Anyway, this is maybe called 7 station. Let's say 4 go to 7. We like 2 minutes, right? So after this is finished, we have this array. This array size is n, right? This is like for this question 200k here. While BFS this one done finished, then we will have like we know for this one, we know absolutely with anyone, right? Any station go to here, we know what's going on here, right? The top one will be 0 here. So after this BFS finished, we know anything bigger than n minus 1. Any number bigger than less than this one go to n. How many times we store this one storing here? This is due during the BFS. So you test your BFS, right? After this one finished, we have this array only like this. Now we can. Now because we know this timing, right? We know when for this question. Let's say for this question, right? For this question, let's say for this question, let's say for example, one, 4, 3, 2, right? For this question, and what for this one BFS, right? So BFS finish here. Once BFS finish, we find out, right? Only 3 can go to 4, right? So basically, what array we have is like, let's say, 1, 2, 3, 4, right? What that mean for this array, for this distance array, it mean like the nodes, each nodes go to n. How long? How many minutes? So one can never go 4. So this is we put some number, right? Put some number. Like maybe infinity, not that too big, okay? Don't overflow. Let's say x2 also x3 we can go 4, so you can take a 1, this one goes 0, right? Similar like this. So when you build this finish, we know 3 can go 4 in 1 second, right? Yeah. After here, for this one we build another one. Say we know like for the 1 station, for station 1 we can go we can take a 0 second for the train, right? Train. For station 2, it take like when you have this array here, we know for station 2 we have 3, right? For station 3, For station 3, we have like, for station 3, we can 2 seconds, right? For station 4, we have 1 second, right? So after this one, we also know what is arriving time, right? Then we can try, right? We can try. So for 1, if we get off the 1, what happened, right? If 1, we didn't do that, we get off 1 here, gotta be infinity. So here, put an infinity. If 2 get off, right? If 2 get off, we got like 3 plus infinity, also infinity, right? Yeah. If 3 get off, right? 3 get off, you can go, right? 3 get off. If I 3 get off, I can using that one to go back to 4. So this is 3, right? And for this one, and this is 1 plus 0 is 1, right? So basically, we brute force all the try here. We say, okay, if I get this station, if I get off this station, what are the result, what I get? So this is built, right? So for this one, it's easy. For the other one, for the sample here, let's say we have another sample here. Yeah, if it's a 1, 2, 3, 4, right? Yeah, it's 1, 3, 2, 4. Let's say we have 1, 3, 2, 4, right? Let's say we have 1, 3, 2, 4. For example, we have 1, 3, 2, 4, right? So for 1, we arrive is what? 1, 2, 3, 4. For 1, 0, definitely. 1 never change, right? So 1 not change. And for this 3 gotta be 1 second, 2 will be 3 second, 4 will be 2 will be 2 seconds. No, 2 will be 2 seconds, 4 will be 3 seconds, right? If you change it to this order, then we get off this one, we say, okay, not good. When we get off this one, also not good. So we get off 3. Get off 3 is 1, right? So 1 plus 1. If we get off 3, we can use this one, go back to 4. So this is 2, and the 4 already arrived. So 4 just using the train, go to here. So 3 here. Yeah, now we know the minimum choice is this one. This is our minimum choice here, right? In this combination here, we know this one is our minimum choice. We're just using the train, go here. We don't need to go to here, and get out. If we see here, if we use here and get off here, and if we go to 3 and get off 3 and we use 3 seconds, right? Not good. Okay. So here, yeah. Now we know what to do for this 1, 2, 3, 4. Now we're dealing with this part, switch, right? So once we build this answer here, so we build this answer. This maybe say this is answer sheet, right? We build this answer here. After you switch, this answer will be changed, right? But luckily, it's only changed 2, right? It's only changed 2. It's not many. When you change 2, only this 2. Let's say if I switch this 2, only this 2 matter. The other 2 doesn't matter because we are answer sheet. This is come from where? This is come from the timetable. This is come from timetable and plus our distance table, right? This distance is based on here. Once you build it, will never change. And the timetable is only switch this 2. Switch this 2, we can easily calculation the time, right? So this is just 2 calculation. If I switch to 3 to 4, and the time will be different, right? So anytime switch, right? Just arriving time switch. So this is also easy. So when you add up this one also very easy. Now we just need to query the minimum, right? So all we want to know is the minimum time, right? So this one exactly is called range update. So update something and query back. We cannot keep doing this way because every time we do this way. So yeah, let's see how long, how many query we have, right? How many query we have? Yeah, this is how many, W is the query, right? W, no, which one is the query? The D. D is the query we have. They say we have this query here. If we have this query, if we keep doing that, so like every time we have this permutation, we keep doing this one where we took like n squared, that's definitely not, right? So that's why in the beginning we say, okay, let's build a like sparse array, because when we build this one costs nothing, build this one costs nothing, and the query this one costs nothing, right? So what do we do here is like we using segment tree to store this one, store this answer, like this answer here, right? Every time when we switch the index, what are we gonna do? We up this timetable here, right? Because time arrived is different. Before is 2, it was moved to here, so he will got 2 minutes, and he will got 3 seconds, right? So different. We got easily. This is mass calculation. So this timetable we update here. So every time when we switch here, we got timetable update. After timetable updated, we based on this one is fixed. So we based on we first do BFS. We already figure out this one. Then we update that guy. This one, right? We up this is to table because only 2 will be updated. It will not be like the other one not moving. So we will go to our like segment tree. Where's the other one? Yeah, we will go segment tree. We only update one node, right? We'll find out what one node, like we'll find out like whatever you arrange somewhere for updated one node, and keep update everything go to up, right? So this is called n log, right? So, and the other one we switch to, because we switch to where it is. Yeah, because we switch to here, we call to update. Once we build this one finished, we update this one, update that one, then we just query the maximum print out. So okay, go to next one, we do the same thing. We repeat that one. So this is just log n, right? Log n. So it's very fast. So once we switch, we update the timetable. Once update timetable, we update this table, and update this table is what you do is you have a segment tree here. When you update this inside, I have 2 nodes here. This is 2 nodes here. Then you just query back, right? Update this. Let's say update 7 and update, and so let's say 4 and 7. 4 might not be here. Just for example, let's say this is the train station 4. This is 7. So we update this too. So you update this one and update this one. Have the value here, value here. When you update finish, it will automatically update up, or update the relative node. This is called n log n, right? After when you query the maximum, because when you're changing this one, everything changes, right? So you can query the maximum. Maximum is here, top, right? Top already we already know. Even the range, even the query the range. So for segment tree, you don't need it here. You can query the range. You can find the correct range here, and find out what is your minimum and a max. Okay, that's the whole thing. So let's read the code, faster read the code, and we're done. So yeah, and basically what we're gonna do here is in the beginning we read this map, we read this adjacent set, right? This adjacent set is reverse. See as reverse. We read A and the B. B is first. B is the arrive table, so we build the B here. Then we just need the destination distance array. We filled like this. This is way enough because our nodes is 200,000. So we add this one is like enough. Then we do BFS. So what to do BFS here is just like keep adding here, right? So if this, so we add this n because we want this special be at DFS. We want to know n. So we use n as first, put n in the queue first, and we keep going down here, and we find if already exists. If already visited, we skipped. If not, yeah, here he do, yeah, here he do this one, so we can, we don't need a, I think we don't need a check here, but anyway, you can be safe to check. We don't need to check. I will test after. Yeah, we don't need to check. Yeah. Okay. So that's the BFS. Or BFS, we know every station use the walkway to go to N. Now we can do the switch, right? We can build a timetable. This is our timetable here. And the size table is a time array and the size array. Time array is this one. This is our time array. This is our size array. Then we build already, right? It's easy, right? This is looping to build. After you build a finished, you build a segment tree. Segment tree, the code is standard. We can use this as a code snap. Segment tree. When you in the beginning, when you give the length, give something, he automatically call build. And we build he calculation the length, and you will be separate by himself. 2 plus 1. Keep building, right? And the building everything, and bring the minimum. So you also can do the maximum here, right? Maximum here. So you can modify here, do the maximum here, right? Then after is the time, real time to switch, right? Now we have the switch. During the switch, we find this one switch. After the switch, you first one we build like the station. What the station look like, right? The station is like here, the real station here, right? Then you build a timetable, and after you build a size table here, you just update the nodes, right? Update the nodes here, update this value here, update the nodes here, right? Update this one. At the end, use query. Update is same thing, right? You see the update code. Update just find it like I just keep finding the left and right to go up. Every time you go up, keep update, and then you gotta find this one, right? Yeah, query. This query is only query the top one. You can also query the middle one, so you can calculate by yourself. You can calculation like left and right, something. You can modify this code. So basically, this is how you solve this problem. So let's conclusion. This problem is when we know how to solve this problem, we're not that hard. But in the beginning, where we stuck? We stuck on the solution here is I think we still stuck in the train. Like every train you get off and get back is useless. So this is the first one. Once you realize get off, get back is useless, then you can say, okay, I will always try. Then we like to get all the case, we gotta try. I get off all the station. I will get off all the station, try my best answer. So we find this one, we do the BFS, we know the best answer, then we try, we get the answer here, right? So when we know try how the answer, then all you know is go to maximum, right? So maximum query, we can do one time maximum query the n is on, right? But the another one we switch, we cannot query this maximum. So this is, we know this technique we're kind of using here is called segment tree. So now we step by step will be solve this problem. Yeah.